refer. Yeah. So the definition of computing environments is where programs are executed. The term refers to different environments. We can call it as IDE, Integrated Development Environment, where programs are executed. We have a three type of environments: standalone, so personal computers; networked, system connected via the internet; embedded systems, microcontrollers in devices like washing machine, dishwasher. So these three are the computing environments. Standalone means personal computers, whatever the PCs that we are using right now, uh, all those are standalone based computing environments. Network means, for example, if we consider any company, any IT company, so all systems are connected, right? Single node or a multi node. So basically, we call them as a multi node clusters, where all the developers sit together and work on a single project. So they connected through internet. So basically, right now we are writing code in our standalone applications. Later, for the integration purpose, we have to choose networked computing environment. So basically, computing environments are three. One is standalone, network, and embedded systems. So standalone means personal computers, network means system connected via the internet. Embedded systems means microcontrollers in devices like washing machine, dishwasher. So whatever, these are fixed program based. You cannot change it as a user or a developer. Next one, computer languages. So programming languages are used to write instructions for computers, right? So we have two different type of languages. One is low level language and the second one is high level language. Low level language means assembly language that human can't understand. Basically, it's for the computers. Whereas high level languages are nothing but C language, Python, Java. These are the examples of high language. Next, next topic: creating and running programs. Write the code using a text editor or any IDE. Next point, we have to compile that code, right? Using compiler, run the executable program. So creating and running programs. So if you want to execute any kind of a program or any kind of application, first step we have to write the code using any kind of IDE or text editor. So right now we are using online GDB, right? So where we are writing our code. Next step, we have to compile the code. Before going to run the program, you have to compile it to fix the errors. Next, you have to execute the code. So example, creating a simple hello world program. So we already familiar with this particular program, right? You can write that program as example of creating and running programs. Next topic, software development method. The software development process involves few steps. First step, whenever you want to design any kind of application or any kind of system, app, mobile app or a web app, we have to follow few steps. First step, problem definition. Next step, planning. Using flowchart, we have to plan our program. Next, design. So design means we have to write some pseudocode algorithm. Next, implementation. And fifth one, testing. Sixth one, maintenance. So under software development method, we have to follow 6 steps. One is problem definition, planning, design. Design is nothing but writing algorithm pseudocode. Fourth one, implementation. Fifth one, testing. And sixth one, maintenance. Next here, next topic, algorithms, pseudocode and flowcharts. So what is the definition of an algorithm? A step-by-step procedure to solve a problem. So let me take an example. At least you will get one question from this module, right? So let me take an example of addition of two numbers program. So I'm going to write algorithm. Find the sum of numbers. So first step, start. Algorithm is nothing but step-by-step procedure to solve a problem. Second step, read two numbers. So numbers are A and B. Third step, compute the sum. So sum is equal to, we have to perform A plus B. Fourth step, print the sum. And fifth one, end. You have to write each and every point. So that is algorithm. So what is pseudocode? A simple representation of the algorithm using plan. So let me write the definitions also. Because algorithm, flowchart, pseudocode, all are important. So algorithm definition, a step-by-step representation. Sorry, a step-by-step approach or procedure to solve a problem. Next one. So I already explained the example. So you have to write the definition and example. Next one, pseudocode. So pseudocode definition, a simplified version of the algorithm using plain language. So a simplified version of algorithm using plain language. So yes, if you want to write the same addition of two numbers program pseudocode, so here is the example. First, we have to write input A comma B. Simple. Sum is equal to A plus B and output sum. So here is the example of pseudocode. So next, flowchart. Flowchart definition. A flowchart is a diagram that visually represents the flow of the algorithm. So a diagram that visually represents the flow of the algorithm. So that's a definition of the flowchart. Let me read the example. Look at the screen. Flowchart example. So input that is A comma B. Next, process, that is sum is equal to A plus B. Next, output, that is sum. A simple flowchart. Flowchart would have input, process, and output blocks to show the addition of numbers. So in next process, next output. So if you observe here, I'm done with algorithm, pseudocode, flowchart. Next topic, applying the software development method. So let's apply the software development method to create a simple C program finds the sum of two numbers. So simply you have to write the same program like addition of two numbers program. Int A comma B comma sum, int F scanf sum is equal to A plus B, int sum. So you have to apply the same programming. See, you have to write one program example applying the software development method means. So next part, introduction to C language. The C language was developed by Dennis Ritchie in the 1970s at Bell Labs. It's a general purpose procedural programming language, POP, procedural oriented programming language, known for its efficiency. So I already explained this topic. C language introduced by Dennis Ritchie. So if you observe here, why Dennis Ritchie introduced this language? Because he just want to develop operating system. So he designed an operating system called Unix using the C language. So that is the main purpose of the C language. So that's a background. Next topic, C tokens. Next topic, C tokens. C programs are made up of tokens, which includes keywords, identifiers, constants, next operators, and special characters. So we have a different keywords like, sorry, we have different C tokens, keywords, identifiers, constants, operators, special characters. So keywords, reserved words. Keywords are nothing but reserved words. You cannot use these reserved words in your program. Like you can use keywords, but you cannot use a variable name int a is equal to 10. Sorry, int equal to 10. You cannot write like that. You cannot use reserved words, right? So reserved words means, for example, int return, printf, scanf, etc. All these are the reserved keywords. Identifiers means names of variables and functions. So example, sum, main method. So these are the examples of identifiers. Next one, constants. Constant values are nothing but fixed values. Operators means symbols perform operations. Next, special characters. So in operators examples, we have different operators like plus, minus, division, modulo division, multiplication, and all. Constant means any constant value, 5, 8, 3.14, and so on. So special characters is nothing but punctuation marks like semicolon, colon, open brackets, right? Closed brackets, all brackets comes under these special characters. Open bracket, closed bracket, semicolon, bracket open, bracket close. All these are the special characters. So keywords is nothing but reserved words. Identifiers, names of variables and functions. Constants, fixed values. Operators, symbols that perform the operations. Special characters, punctuation marks. So let's take an example. If you observe here, I have int a equal to 5. So here in this example, int is a keyword. Next, a is a identifier. 5 is a constant value. Is equal to is a operator. Semicolon is a special character. So here we have a total 6 C tokens. Keywords, identifiers, constant, operator, special characters. So not 6, 5. Right? So I hope you understand what is C tokens and the examples. Next, after C tokens, we have a concept. Identifiers are done. Next topic, basic data types and variables. So what is basic data types? So basic data types are integer, float, character, right? So data type definition is providing a memory location to a variable. That's the definition of data type. Providing memory location to a variable. Providing memory to a variable or a space, right? So next one, variable. So variable is nothing but providing a name to a value, right? Or we can also call it as named storage locations data. So if you observe here, I'm going to write int a equal to 10. So here in this example, int is data type. A is a variable, right? So a int defines the memory, bytes of memory. A means providing a name, a value. So here my value is 10. I'm providing a value 10, right? So that's all about the variables and basic data types. I already explained these constants. Next topic, preprocessors directives, right? So what is pre-processive directives? Pre-processive directives begin with hash. So pre-processive directives are starts with this hash symbol and are processed before compilation. So we have pre-processor directives, that is one hash include, right? And second one hash find, right? So these are the pre-processor directives. So hash include standard libraries. Define includes define constants. So the definition of preprocessor directives is preprocessor directives begin with hash symbol and are processed before compilation. So whenever you are going to write any kind of a program, so it will define, uh, automatically you have to define these preprocessor directives. So compiler will execute them before the compilation. So if I write any example program, for example, let me write one simple example program. So here I have a hash include, right? So now this include standard libraries, whatever the libraries like string.h, math.h, or random.h, that is nothing but rand.h. All these are the standard libraries. So whenever you are going to include them in your program, you have to use the preprocessor directive, that is hash include. Now I am going to write one more directive, that is hash define. So here I'm defining the value. So hash define means it defines the constant values. So I want to define one constant value, that is value is 3.14. Right? So now I'm going to write the program. So here float r, I want to give some radius value, that is 5.0. Now I want to calculate the area. So float is equal to area A is equal to pi, that is pi value into radius r into r. So what is the formula to calculate area? Pi r square, right? Pi r square means pi into r into r. So you will get the area. Now I'm going to print that area. Area A is equal to, so as it is float value, I'm going to use a format specifier, that is modulo division 2f. And I have to call a value, right? So let me execute this. Before that, I have to select the language. See, 78.50 area of circle. Here I calculated area of circle using radius, right? So formula is pi into r square, pi r square. Area is equal to pi r square. If you observe here, I used one pre-processor directive, that is hash include. I defined one constant value, that is pi. So I'm going to use that value directly in my program, right? So there are only two types of pre-processor directives in C programming language. First one is hash include. It includes the standard libraries. So you can write the example. Standard libraries are standard input output dot h, string dot h, um, srand.h, next rand.h, all are comes under these particular standard libraries. Hash define means you can define any kind of a constant values using hash define. So yeah, that's all about pre-processing processor directives, pre-processor directives. So next one, manage input. Yeah, you can observe here. Pre-processor directives include define. Yeah. Manage input output functions. So formatted input output uses printf for output and scanf for input. We already know where we have to use printf, where we have to use scanf. Printf is especially for the output and scanf for the input. Next one, operators. Operators and expressions. So operators, we have arithmetic operators, the plus, minus, next multiplication, division, modulo division, right? Next one, relational operators, comparison operator, not equal to operator, less than, greater than, less than or is equal to, greater than or is equal to. All these are relational operators. Next one, logical operators. Those are and or nor, right? So we have a bitwise operators. Bitwise operators means single and single or, right? So these are the basic important operators. And expressions is nothing but we are going to write the expressions using the operators. Next, precedence and associatively. Okay, associativity. Yeah. So operator precedence determine the order of evaluation. So it defines the order of evaluation. Associative defines the order in which operators of the same precedence are evaluated, left to right or right to left. See, operator precedence is nothing but it determines the order of evaluation. So, for example, I have, so let me write one simple value, that is result is equal to 10 plus 20 into 2. So in this example, multiplication is evaluated before the addition because multiplication will have high precedence. So 20 into 2, you will get 40. Next step, 10. 40 plus 10, 50. So you will get R value 50. So multiplication is evaluated before the addition. So that is the precedence and associative expression evaluation. Okay. Type conversion, very, very important topic. So type casting or data type changing or type conversion. So we have two different type castings are available. Type conversions are available. First one, implicit. And second one, explicit. So what is implicit? So it is also called as automatic typecasting. So automatically done by the compiler. So basically, type conversion is different. Type casting is a different. To be frank, Type conversion is nothing but changing data type from one format to another format. That is the exact definition of type conversion. So implicit conversion means yes, automatically done by the compiler, but whereas explicit conversion, user should do it based upon his requirement. So we have to call typecasting is the explicit conversion. So explicit conversion means changing the values from bigger one to smaller one, bigger data type to smaller data type. Smaller to big. Um, so type casting is a different, type conversion is different. So let's see the example. So here I want to declare one integer value, int a is equal to 5. Next, I want to declare one float value, float t equal to 2.0. Next, result, float is equal to result r. Float r is equal to a by b. So print f on the result. Result r is modulo division to f, and let me call r variable. Let me execute it. See, there is a warning. So 2.50 result is correct, but if you observe here, warning format f expects argument of a type double, but argument 2 has the type int. So this compiler is smart, online GDB. That's why you got the output. In case if you execute the same program in an older version of the IDEs like Turbo C, you will get an error. So here have to convert the a value into float value. So just typecast it using float keyword. Now let me execute it. Printf a. Okay, sorry. Sorry. Yeah, I told you, right? This compiler is smart. So here is the result 2.5. So let me add float and execute. So there is no change in the output because automatically typecasting done by the compiler automatically. So we have advanced IDEs automatically done by the compiler. Don't worry about manual casting. So type conversion, simple C programming example. We are done with the first module. Basically, this module provides a solid foundation for understanding the C language. So I hope you are done with the first module. From second module, it's quite important, right? Because lot of technical information is there from the second module. So if you have any questions from your first module, please let me know. So let me start the second module. If you don't have any kind of doubts from the first module, I'll start the second. Yeah, second module is conditional statements and repetition statements. So in this module, we will learn about conditional statements. Guys, if you have any kind of a questions from the first and second modules or from any module, I'm always available. Please message me because your exams are very near, right? So if you have any kind of a questions, I'm always there to help. Okay? Yeah. Conditional statements and repetition statements. So in this module, we will learn about conditional statements used to make decisions in the programs. Basically, conditional statements means they will use to make some sort of decisions in the program. Guys, wait a minute. I received an email. Just a minute. And can you explain an example on post increment and pre increment? Yeah, I'll do that. Don't worry. Ma'am, explain about recursive and non recursive functions. Okay. Yeah, I'll do it. Anyways, tomorrow we'll have class, right? So I'll explain. I'll include these 2 points. Functions. Uh, anyways, I have to explain the functions topic. That time I will explain this recursive and non-recursive functions. And increment and post increment and decrement, I will explain that also. You don't worry. Especially in the for loop, I will explain. Okay. So conditional statements used to make decisions in the program, and the second one, repetition statements. So especially these repetition statements used for looping, right? So conditional statements are different. Repetition statements are different. Repetition means loop, right? So we'll go through each topic step by step with examples. So conditional statements. Conditional statements control the flow of the program based on certain conditions. So conditional statements control the flow of the program based on certain conditions. So first one, simple if statement. So the if statement executes a block of code only if the given condition is true. If the condition is false, it will jump to the else block, right? So you can write any kind of example program like A greater than B kind of a program. So simple if statement is a conditional statement. And the second conditional statement is if else statement. The if else statement provides an alternative block of a code to execute if the condition is false. See, first conditional statement is simple if statement. If the statement executes a block of a code only if the given condition is true, right? So if else statement will provide an alternative block of a code executes the if the condition is false, right? So and the third conditional statement is if else if ladder. The structure is used when there are multiple conditions to check. So just a minute. So conditional statements. So first one is simple statement. Second one, if else statement. And third one, if else if ladder. Right? And fourth one is nested if else statement. So we can consider switch is also a conditional state. Switch statement. Right? So simple if statement means executes a block of code if the given condition is true. So if else, it provides an alternative block of a code to execute if the condition is false. If else ladder, if you want to execute multiple conditions, you have to use if else ladder. Next, nested if statement means the statement can be nested within each other. The definition of the nested statement is if statements can be nested within each other. So I just want to give example of nested if, because we are already familiar with the if else ladder, right? So let me explain this nested if with one example. Okay, first let me explain if else ladder so that I can explain the second one also. So here I have int n is equal to 0. Next, I'm writing one simple program. Don't worry. I'm writing a condition if n greater than 0. This is simple if statement. So here printf number is positive. Number n is positive number. Right? So this is the example of simple statement. Next, if else means you have to write the false statement. The number is negative. So instead of that, I'm writing one more condition because I'm using if else ladder. If else if ladder. So else if the number n less than 0, number is negative. So let me write else statement also. So if both conditions are false, so the number is 0, right? So let me execute it. So the number is 0 because I provided n value 0. If I write 10, so what is the output? The number n is positive. So here is the example of if else ladder. Now I want to convert the same program for the nested if else statement. So if statement can be nested within each other. So here I have to change if n greater than 0. I have to write one more if block within the if. So let me change this code. Nested if means I have to write if within another if. So here I have a statement that is if n greater than 0. I'm writing one more condition. If number n modulo division with 2 double is equal to 0. This condition true, the number is positive, right? Positive and even number. We can provide one more statement here. Printf, the number n is positive, at the same time even number. If this condition falls, that means we have to write one else statement over here for this particular n modulo division by 2. Here we have to provide a statement if n modulo division 2 is not equal to 0, then the number is negative and no, no, no. Number is positive, but odd number, not even number. So here, this is a nested if loop. So if within if method, I have another if else method. So now I'm going to write else for this particular value. Just a minute. Else if n is negative or 0. I'm writing only one statement here. See, I provided n value 10, so n is positive and even number. If I write n value 3, showing the same. 3 greater than 0, 3 modulo division by 2. No. Why it's showing the same? 3 is not an even number. Yeah. See here, odd. N is a positive number and odd number. I got the correct out. Right? This is the example of nested if loop. If within another if. Nested if. So you will have a one parent if block. Within that, we will have one child if block. So you have to provide these particular braces uh, to overcome the ambiguity. So always use braces to avoid the confusion. Otherwise, you will get a lot of errors and you cannot understand which line of a code is related to which particular statement. Here, this print statement related to my n modulo division 2, right? So you have to always provide braces to avoid the ambiguity. Next, switch statement. So switch statement means it's used to select one of many code blocks to be executed, right? So all these are the conditional statements. Next one, repetition statements. Repetition statements are nothing but loops. Repetition statements. So first one, while loop. So loops are used to repeat the block of code. And the second one, for loop. And third one, do while loop. And fourth one, nested loops. And we can consider the break statement is also a repetition statement. And sixth one, continue. And seventh and important repetition statement, that is go to statement. So all these 7 statements comes under repetition statements. While loop, for loop, do while loop, nested loop, break, continue, and go to statements. So repetition statements are nothing but it will repeat a block of a code multiple times. So whereas a while loop, the while loop repeats the block of a code as long as the condition is true. I'll give examples tomorrow for each and every topic. For loop, the for loop is used when the number of iterations is known beforehand, right? So I already explained the difference between for loop and a while loop. The for loop is used when the number of iterations is known. Next, do while. The do while loop executes the block of a code once before checking the condition. Nested loop means loops can be nested within each other loop. Next, break statement is used to exit a loop permanently. Continue statement. The continue statement skips the current iteration and moves to the next statement. Next, the last statement, go to. The go to statement transfer control to a labeled statement. So tomorrow I will explain each and every repetition statement. So let me open the syllabus copy once. Yeah. So if you observe here, under repetition, we are done with these conditional statements. Simple if else, ladder, nested if. Oh, I have to explain this Angeling else problem. Okay. So basically, this dangling else problem occurs when there are multiple if statements without proper brackets. I was talking about brackets, right? To avoid the ambiguity. So this problem occurs when there are multiple if statements without proper brackets. So always use brackets to avoid the confusion. Ma'am, tomorrow please explain switch case. Okay. Okay, I'll explain switch case also. From switch case 2, I'll start these repetition statements while, for, do while, nested looping, other statements related to looping, break, continue, go to. Okay. So I'll finish this second module and third module tomorrow, where I'll explain functions. Uh, few of you asked what is recursion, right? And uh, under loops, increment, decrement, post increment, right? I'll explain all these topics tomorrow. Yeah. Thanks, everybody. Good night.